everyone, again my name is Ricame Escasabana from ECE31 and welcome back to my YouTube channel. So for today's episode, we will be tackling about experiment number 2 or digital input of our Digital Electronics 2 subject, and with that, let's discuss our objectives. Our first objective is that to be able to learn how to create a project and build a project. Second, we aim to understand how the final code program to the microcontroller, and third is to create a simple code for controlling an LED. So our equipment and components that we will be needing is that we need, again, our IC, the same IC that we needed from our experiment number 1, which is the PIC16F18875, a 220 ohm resistor, an LED, any color of your choice will be good, a breadboard, connecting wires, our Pickit 3, and of course our 5 volts power supply. So now we will be following our procedures using our Mplab XIDE. I hope you'll enjoy. Keep on watching. For our procedures, which includes our part 1 for our digital input board, we need to create a new project, just like what we are doing before, and then we have to choose microchip embedded, and then standalone project, and then again we will be using the same Pickit, the same IC that we used before, which is the PIC16F18875, and then let's select it, and then let's click next, and then we will be selecting our compiler here, and then let's click next, and then we will be renaming this Casablanca with my initials, and then it's experiment number 2, and then the same, select your folder, and then set as main project, and then click finish. Then after that, let's just wait for the Mplab XIDE to load up, and then after that, let's again go to tools, embedded, and then Mplab code configurator here. Then let's just wait for it to load up, and then after that, let's go to our projects. So there will be a pop-up here. Let's just save this one here. Okay, now let's go to our peripherals, which is the system module, the pin module, and the interrupt module, and this will be automatically included when we launch our MCC. We need to open our pin manager here, and then let's click port A. Okay, so this port A, and then we will be utilizing pin number 4 or RA4 here. Okay, and then we need to click the output here, and we will turn it to blue lock symbol, which is connected to our D2 LED. So let's click it. Then after that, it should be turned green here, the output, and the input should be orange, and it should not be locked, as seen on this image. And then after that, let's go to our pin module here, and then we will be setting up our parameters here. But before we forget it, so let's go back to our system module, and then let's consider port B as well. Okay, so port B or pin number 37 here, and we will be, let's not forget that for our input, we will be doing the same that we did here on port A to port B here, which is our RB4. So RB4, and then we will be locking the input. So that's for our input here, and then our output will be unlocked. So same with our port A here. This should be green, and this should be color orange. And now let's go to our pin module. Then in our project resources section, we should always remember that in this experiment, the RB4 here will be the input that will read our switch. So the wick pull up or the WPU box should be checked here on RB4. And then for our RA4, here it will be our output, and it should control our LED. So we should click the output box to make the pin an output. So we should untick analog. So as you can see, this should only be the 2 boxes ticked here on our end. Now, before we forget, we have to declare the name of our circuit components. So first one, we have to go to our pin module, and after setting the output and ticking our WPU here, we have to name our LED or our bulb or our light to its custom name, which is LED. So this will be our output. And then for our digital input, we will be renaming it to switched here, as you can see. So it is needed for our code to run. Go to our system module here, wherein we will be editing our simulation or our code settings. In this section, the oscillator settings and the configuration settings are being selected. So for our oscillator select, we should select HFINTOSCE here, and we should select HF internal clock with a value of 4 megahertz, and then we should select 4 for our clock divider here. This will enable the internal 1 megahertz internal oscillator as the system clock. So this should be our system here, and don't forget to check our low voltage programming enable checkbox here on the bottom, and then we should click generate code button to have our MCC create the software libraries for this project. So we just have to wait for it to load up so that it could create the software libraries for our project, which will allow us to create our source code to program our IC. Now, after that, we should have here on this part, okay, let's go here. We should have both the generated header files and source files, as you can see here. So it's a lot. There are a lot of files already, and it should also have a generated main.c file. So let's go to our source files, and then as you can see, this will be our main.c file. So we have to double click on our main.c file here to open it up in our editor window. And with this, we will be adding our source code to the end of our main.c file. So let's just find for while here on our end, and then so here's the tip. So for you to avoid having errors on where to write your codes, you have to make sure that you are on the right file. So here on my end, this is our main.c file for our experiment 1. So let's go to our source file here for our experiment number 2, and let's open our main.c file here. So let's find the while one, and here on this area, we will be typing our code for our experiment number 2. So we will be typing our code. So let's type it here. If switch and get value, open and close parenthesis, is equals to 0, meaning logic 0, then our paste here, then LED will be set high. So open and close parenthesis, and then semicolon, and then our bracket here, and then else our paste here, LED set low, meaning if we get a value of logic 0 from our input, then the LED will be set high, meaning it would turn on. But if this condition is not satisfied, or if the code is not satisfied, then the LED will turn off. So that's our program for our experiment number 2. Again, you have to take note that you should be always careful with the right spacing and indentation of your program, so it should be working. Okay, so this is our final code for our experiment number 2. So following up our source code layout, so this is our final code here. So with this program, we will be able to give or input, let's say put an input to our circuit, and then after putting an input that could satisfy the condition of our code, then the IC will be performing the function, and then it will help in delivering the output we desire. So that's the logic behind this program. And now, after adjusting it, we will now go to our projects, okay? And then on our source files, let's go to main.c, and then we already typed the code a while ago, and then we will build our program. Okay, so we just have to wait for it until the build successful pop-up here will show up. So now we will be going to the Mplab XITE. So let's just close this one. So before you go to Mplab XITE, you have to make sure that your Pickit tree is already recognizable or recognized by your computer. So now this is our Mplab XITE. So now let's connect our Pickit tree, which is already recognized by our computer. And then there will be a pop-up here, so we have to edit our settings here. Again, the password is microchip. Okay, we have to log in. And in this part, if you can still remember, we have to edit its power settings, setting our voltage levels to 3.125, and then taking this part, power target circuit from Pickit 3, and then we have to browse our hex file from the Mplab IDE, which is our experiment 2 here, which will be the source of our code, okay? And after that, we have to click the program button here. So make sure that your Pickit is recognized by your computer, and there will be a pop-up here saying programming complete. So now we will be constructing our circuit to test the correctness of our code. So we will be needing LED, a 220 to 360 ohm resistor, or maybe just at least 1K, okay? So we will also be needing a tactile switch, okay? Rocker switch can be good as well, but a tactile switch will be better for our simulation since it will be mounted to our breadboard. And then we will be needing our connecting wires. So for our experiment, we put our output, which is on our RA6, which is on RA4, which is on the pin 6 of our IC. So we will be counting. So our RA6 is here. So let's connect our connecting wire here, which will our resistor and our LED will be connected. So for our next connection, we considered our RB4 for our switch. So let's count it. It's on the pin 37 of our IC. So 40, 39, 38, 37. So this will be our pin for our switch. So let's connect it here. And then we will be connecting our tactile switch on this connection. Okay. So let's put our tactile switch on the center of our breadboard. And then after that, let's put a resistor on an LED first on our pin number 6 of our IC, and then do not forget the 360 ohm resistor here so that our LED will not be shocked by the voltage. And then do not forget the proper grounding of our circuit, which is this one. We will ground our LED here. So let's put a negative polarity here, and then let's ground our tactile switch as well. So this one, let's ground it here, and then we will be connecting our VDD, which is connected to the positive supply of our breadboard. So VDD is our pin number 32 of our IC. So this is pin 37, so 38, so 36, 35, 34, 33, 32. So this is connected to our positive supply, and then our VSS will be connected to our negative supply or to our ground. So this will be our circuit for our experiment number 1, which is the first part. So now to test our circuit and to prove the correctness of our code, let's turn on our power supply. So our logic here is that when we put, or let's say consider, a digital input through a switch, which is our tactile switch here, meaning if we press our switch to create a digital input, it should create a digital output through our LED light here, meaning the LED light should light up. So that's the logic of our source code. So let's now check it. So as you can see, every time I click the switch, okay, there is a digital input which is recognized by our code, and then after that, there is a digital output which is delivered through our LED by lighting it up. So let's try it again one more time. So you can hear the sound of our switch. Every pressed corresponds to a digital input which delivers a digital output. So that's the logic of our part 1 for our experiment number 2. Now for our second test, we will be editing, or let's say trying our program or our code by which our LED should light up at 2 seconds interval. So now we will be changing our code. So let's say if switch get value is equals to 0, then we can consider that we can set a delay for our program, which is this one. So delay, then let's change this one to MS, and then let's make it to 2000, since 2000 milliseconds is equals to 2 seconds. Then let's change this to LED, then toggle. Then let's not forget our open and close parenthesis here, and then our semicolon, and then after that just leave it there. Else statement, and then LED set low, meaning LED will be off if the condition is not satisfied. So that's our code for our second condition.
So now we will be testing our circuit. So we will be considering the same circuit on the first part, but now different code. So we will be testing the 2 seconds interval. Once we turn on the switch for our digital input, it should output, or the LED should light up for an interval of 2 seconds. Okay, so I'll switch it, and please focus on the LED. Thousand one, 1002, 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002. So that proves that our source code is correct.
Let's modify our program by lighting up our LEDs in RA1. Okay, so our output here in RA1 will be locked, and of course our RA2 here, and then our RA3 and our RA4. So all of the LEDs connected in those ports will light up. If our RB4 here is pressed, or our switch is pressed, so now let's edit our code. So let's go to our main C. So we will modify our code. So the button will be pressed in 1 second, and our LED, our 4 LED will light up. So let's copy this one. So let's set high for LED, then let's copy all of this. But before we forget, let's first rename our LED. So LED1, and this one will be LED2, and this one will be LED3, this one will be LED4, and then it is our switch. So let's go to our main.c file here, and let's copy all of this here. So LED set high, and let's copy all of that, and we will be renaming it. So LED1, then LED2, LED3, then LED4. Then let's copy this one, and let's paste it here. Okay, so let's place it here, because if the condition is not satisfied, then the LED will remain off. So let's just edit it. LED1, LED1, LED2, LED3, and LED4. Now let's build our code. Okay, so let's check our configurator for our pin manager here. Before we forget, let's untick analog here. Then let's go to our main C file. Then now let's build the project. So as you can see here, there will be a pop-up, build successful, and then now we will be connecting it to our Pickit 3 again. Now let's go to our Mplab XIPE, and then let's connect our Pickit. So this may take a while. Now let's browse our new hex file, and then now let's click program, and then the programming should be successful and complete. So now let's test it in our circuit.
Now to set up our circuit, we will be connecting 4 wires in our IC. So for RA1, it will be the orange wire, and then for RA2, so let's connect it here. So for RA2, it's the yellow wire here. So let's connect it here as well. And for our RA3, so it is the red wire here. So it's on this part of the breadboard. And for our RA4, which is for our LED4, it's in this part. So let's just move our wires here so that our resistors will have enough space when we connect. There's the LEDs with our connecting wires. So now let's connect our LED. So let's put on our red LED here. Okay, so let's ground our LED here. So it's important that we ground them so they will all light up. So next one will be our blue LED here. So let's connect it. Then let's ground it as well. And next one will be our green LED here. So let's connect it here. And then let's ground it as well. Okay. So, and last one, it will be our RA4 or our output from RA4. So let's ground it as well. So overall, we have 4 LEDs connected. So, and don't forget the connection of our output and our tactile switch here. So that's our circuit for port 3. Now to test our circuit, we have to check if all of the 4 LEDs will light up if we press our switch for 1 second. So let's turn on our power module. So as you can see, all of the 4 LEDs turned on when we pressed our switch.
As a conclusion, using Pickit and Mplab IDE, IPE software, electronic components like integrated circuits, light emitting diodes, LED, and switches can be programmed to serve as digital output and input in a circuit. This way, it is proven that digital electronics is really a great help in controlling and manipulating a circuit according to project requirements. So this will be the end of our experiment 2, the digital input and output. Again, my name is Rogami Escasubuena from ECE31. I hope you learned something from our episode for today, and I hope I will be seeing you on our next vlogs. See ya!